Alrighty, so last unit we were graphing real life situations on the x and the y axis. I start with real life situations because it's easy for you guys to understand. Oh, I worked for 5 hours, so my pay went up to $100. I got paid $20 an hour. Shoot, easy peasy. Of course, the reason that we use this and learn how to graph is because it applies to numbers all over the place. So we are going to work on doing the same concepts that we had last unit, but we're going to apply them to all math, not just one situation, like water dripping out of a bucket or something like that. Okay? So instead of having hours, pay, or distance and time, we just have x and y. All right? X is still the domain, y is still the range, so none of that changes. But instead of d's and t's or s's and t's or q's and p's, we just use x and y. Everybody cool? All right. So you guys are smart kids. An x-intercept. What does intercept mean? Where it goes through. So the x-intercept must be what? Where the line goes through what? TJ is waving his hands around like a cheerleader. Yes, it's where the x goes through horizontally. So all of you should draw somewhere maybe up here where you've got some blank space. One of these. And then let's put a line through it. Now you guys are smart kids. The black line is the line that we have graphed, yes? You can quite plainly see that that line crosses the x-axis how many times? Once. Will it ever cross it again? No, because that line will continue to go up and to the right and down and to the left. Everyone agree? And, of course, you're also very smart kids. You notice how many times does it cross the y-axis? Once. So, an x-intercept and a y-intercept, every line will have one of each. Everybody cool? As long as it's a straight line. We'll talk about other stuff later. But for now, everyone's good with this, yes? All right, now. So the x-intercept is the point on the x-axis where a graph line crosses. Okay, so smart kids, what's the y-intercept? The point on what? Jack? The y-axis. Right, the point on the y-axis where a graphed line crosses. Now, you guys are smart kids. When I leave you that much blank space, you know we're doing something with it, right? Mm-hmm. All right, so everybody draw a big one of these, a big Cartesian plane. Yes. And all of you, every single one of you, put a dot somewhere, anywhere on the x-axis. Put your dot anywhere. Everybody made a dot? Excellent. I'm going to make my dot red to go with the fact that I wrote the x-intercept in red. Is everybody cool with that? Everybody good? Okay. Tell me what you know about this point's coordinates. Okay? But to be a coordinate, it must have an x and a y, correct? So what is that guy's coordinates? Jack?
X is unknown, but we know that's on the line. No, 0 is x. X is 0.
X is 0?
No, x.
Y is 0.
Y is 0. What's x? Unknown. So what do we do in math when we have an unknown?
Variable.
We make it a variable. What variable should it be? Why should it be x? Because it's on the x-axis. Everybody cool? So now, somebody tell me where you put your dot.
Around that location.
Did anybody put their dot over here? Okay, I'm putting a dot over here. What do you know about that dot's coordinates?
Negative X.
It's an x, and what's its y? 0. What if I put my dot here? X, what's its y value? 0. So, now something has happened in math 3 times. I have 3 x-intercepts.
It's a linear relation.
Right? What does that tell us about every x-intercept? Mason. It would be. You're absolutely right. But it's still some unknown value of x. And I'm getting to where we're going with that in a minute. Thank you for noticing. What does that tell you about every single x-intercept? What are they all? If these 3 look like that, what is every other one?
Like that.
Just like that. So every x-intercept is x comma 0, yes? Everyone agree? Some value of x, but the y value is always 0. Now, you guys being the smart kids that you are, take your pen or pencil and give me a dot anywhere on the y-axis. I'm going to put mine down here. And I'm doing blue because I use blue ink for the y-intercept. What do you notice about that guy's coordinates? It's 0, y. What do you know about that guy's coordinates? 0, y. So what does that tell you about every single y-intercept? It's 0, what? Y. Always. Is everybody with me? Because it's some unknown value on the y-axis. I know what you're doing, but I make the jokes here. Okay?
Because at least yours are funny.
What?
If you put it dead in the center, right between where it crosses.
Right there?
Yeah, would you still say, would you put it at 0 and 0?
Yes.
Okay, just wondering about that.
Because that point, its x value is 0, so it's not unknown. And its y value is 0, so it's not unknown. So it's 0, 0. Everybody cool? All right. So, look at what we have here. I have asked you for the x and y intercepts of this. Now, the way I've written this is weird, because the way I've written this is the way we finished our last unit, yes? Okay. I have asked for an x and a y-intercept, but you will notice there is no what in that equation. What's missing? There's no y, is there, Tavleen? But there is a y, isn't there? Because the y's are the output, yeah? So which of that is output? Is it the f of x or is it the x? The f of x is the output. So I can rewrite this as y equals 2x plus 3, correct? So now I am looking for the x-intercept, which I do in red. Every single x-intercept is what? X comma 0, yes? We just learned that, right? Okay. The x is an x value, and the 0 is a y value, correct? Everyone agree? Well, I have this equation, y equals 2x plus 3. And I have an x value of x and a y value of 0. What do you think I can do with those two pieces of information? Pardon me? If y is right there, and y equals 0, what can I put there? 0. So I could put 0 equals 2 what? X plus 3. What do you do in math every time you see a variable and an equal sign? What should you do? Solve it. Which means what, Brianna? What do I have to do to that x? Yeah, you isolate him, right? How do we isolate that guy from the 3rd grade? Take it. First, I divide it. We're trying to get x by itself. So what should I do first? Minus 3. Where else? Great. Negative 3. So negative 3 equals 2x. Now what? Divide by 2. So what does x equal? Negative 3 over 2, right? Do I have an x written somewhere on this page? Where? It's right there in red, isn't it? Well, if x equals negative 3 halves, then what goes there? Negative 3 halves, right? So what's my x-intercept? 1.5 comma 0, right? Now, what is weird about the way I've written that makes it a pain to put on a graph? It's a fraction, right? So what if I do this, though? What if I make that 1 and that 2? Does that allow me to find 3 halves easily? Where is 3 halves? It's 1.5. But what do you notice? It's negative. So I got to go over negative 1.5, and I put a dot. Does everybody follow the x-intercept? We're going to do a bunch of it. If you're even at sorta right now, you're in good shape. Now, you guys being the smart kids that you are, I also need a y-intercept, don't I? Y-intercepts are what? What is a y-intercept? 0 and y. The x value is what? 0, and the y value is y. So I have y equals 2x plus 3, correct? What can I put in there? The x is 0, so what do I write there? So y equals 2 times 0 plus 3, right? What's 2 times 0? So y equals 3. So where do I put my dot? Y equals 3, but I got to be careful because of the way I graphed x, right? I got to go up 1, 2, that's 1, 2, 3, that's 2, 6, there's 3. Does everybody understand? That's where I lost you? Okay. What did I do with the x's so I could put 3 halves on the graph easily? I changed the scale, so each square was worth a half, correct? So if I change the x scale, what do I have to do to the y scale? Same thing. So I go up half 1, half 2, half 3, and there's the dot. Now what can I do when I connect those dots? I just gave it away. What can I do with those 2 dots? Why? No, you do not have to connect because it's linear. You have to connect because it is... Even that's not the reason to connect it. The reason to connect it is because it's a certain type of data. Which type? It's continuous. Why is it continuous? Can I take any number in the universe and multiply it by 2? And then add 3 to it? Yes. So because it's continuous, we draw a straight line. Now you guys are smart kids. If I went down 6 and over 3, and that line's going to go on forever, where's the next dot going to be? Down 6 and over 3. And then I could put another dot. Is everybody cool? At least sort of. On a scale of 1 to 5, you're sitting at least 2. 5 being, I got this, shut up, let me do my work. And 0 being, X's and Y's? What are you talking about? Everybody's at least a 2? All right. Just to remind you from last day, or last unit, what would the domain and range be? We've already talked about it. How far to the right is this line going to go? Forever. How far to the left? Forever. So what's the domain? X is a set of real numbers. Because I can put in every single number, can't I? What is the range? Same thing. Y is a set of real numbers because it's going to go up and down forever. Everybody good? All right, let's try to do one that's a little bit harder. Turn the page over. What makes number 3 a little bit harder? It's got a fraction, but are fractions anything to be scared of? Of course not, because we know how to do math. What is every single X-intercept? No. 0. There you go. X, 0. What is every single Y-intercept? 0, Y. What can I do with that X when I see right there's an X? I can put that X in there, can't I? So that's 1/2 times X minus 2 equals, that's a Y value, right? Y values are outputs, right? Is that an output? So what does this equal? 0. Do I know how to solve that? Sure I do. How do I get rid of minus 2? Add 2, add 2. 1/2 X equals 2. How do I get rid of divide by 2? You times by 2. What happens to those two 2's? They cancel and I have 1x. Would I ever write 1x? No, I just write x. What's 2 times 2? 4. X equals 4. What letter is that? So what does x equal? 4. So what is the x-intercept? 4, 0. Where do I put my first dot? 1, 2, 3, 4, and 0. That doesn't seem too difficult. What's the y-intercept? What is every single y-intercept? 0y, correct? So y goes in for the output. Y equals 1/2. What's x here? 0 minus 2. What's 1/2 times 0? 0. What's 0 take away 2? -2. So y equals -2. What does that mean that y equals? So what's the y-intercept? Where do I put the dot? -2. And what can I do with that? Those two dots? Connect them. Where's the next dot going to be? Down 2 and left 4. Where's the next dot going to be up here? Up 2 and over 4. And I can make my line. Is everybody with me? Now I want to show you guys something that some of you might have noticed, but some of you didn't. Probably. What's that? +3. What was our y-intercept? +3. What's that? -2. What was our y-intercept? Something just happened twice in math. How often will it happen? Every single time. Does that look like g of x equals 1/2 x minus 2. Does that look like that? Really? I think it does. There's a number multiplying by x. Is there something multiplying by x? Yep. Plus a single number. Is that a single number? Great. Does it look like this? F of x equals 2x plus 3. Does it look like that? Yeah. Right? So, if I have this form, and this form is called slope-intercept form, and in slope-intercept form, that is any time y is isolated. If y is isolated, you have slope-intercept form, right? And if you have slope-intercept form, what do you know b is? That's the y-intercept, isn't it? Because we just proved that twice, didn't we? And how many times do we have to prove it in math? Once might be an accident. 2 is pretty good bet. What's 3? Guaranteed, right? Okay, so you guys are smart kids. So we know what y and x are. They're just dots on the graph, right? And we know that b is the y-intercept. What's the only part of this equation that we haven't talked about? Now, we've talked about x and y. M. We haven't talked about m, have we? But I want to show you guys something. Where's the next dot here? Where would I go if I was going to the right? Where would the next dot be? Up to and over 4, right? Right there, yeah? Okay. And this dot was up to and over 4, wasn't it? This dot was up to and over 4, wasn't it? So if I'm going, I've got 2 on the y-axis, right? So I went up 2, and then I went that way 4, correct? Make that a ratio. How far did I go up compared to how far I went sideways? I went 2 over 4, didn't I? Which was what? 1 over 2. What do you notice there, there, and there? They're all the same thing, aren't they? So what does the m tell us? It's the ratio of up, over, up and down, over, left to right. Is everybody cool with that? Which is what we call, you guys are smart kids, if that's the intercept, we already know what x and y are. What's m? The slope. Slope. Now, we have to talk about slopes. Here I have 4 lines, correct? Those are the only kind of lines you can have, right? It can either lean that way, not lean at all, or be totally flat. Everyone agree? All right. So, here is point A. Here is point B. Is everybody cool with that? If I, Mr. Myers, want to get from point A to point B, and I am on a graph, how would I do that? Describe to me how I could get here, but I'm not allowed to walk diagonally. I would go up, and then what? Turn right. Does everyone agree? On a graph, what values are associated with up? Positive or negative? Positive. What values are associated with right? Positive or negative? Positive. So if I was going to make the ratio of up and down to left and right, I would end up with a positive number divided by a positive number, wouldn't I? And 2 positives make what? A positive. So this is what we call a positive slope. Now you guys are smart kids. What if I'm already at B? Then how do I get to A? It's opposite. I would go down, negative, and then I would go left, which is what? Negative, which means I would get negative divided by a negative. Two signs the same. What do I get? It's still a positive slope. Does everybody understand? All right. So now I'm going to use green to do this one. C to D. How do I get from C to D? Okay, I'm going to walk down here. Is that positive or negative? Negative. Then I'm going to turn right. Is that positive or negative? Positive. So that is a negative divided by a positive. Two different signs means what? A negative slope. Does everybody understand? What if I reverse it? I'm going to use gray. What if I got to get from D to C? Then I'm going to go up, which is what? Positive. As soon as the line shows up. That lasted a long time before it crapped out on me, didn't it? That's like a record. Positive, and then that way is what? Negative. Two different signs means negative slope. Is everybody cool with positive and negative slopes? All right, now look at the straight up and down one. You can have a positive slope. You can have a negative slope. What kind of slope do you think that is? I've got a guess for neutral.
I agree. I concur.
We got a bunch of concurs. Okay. In what sport do we often use the word slope? Skiing and snowboarding, yes?
Yeah.
All right. So, here is me on my snowboard. Everybody cool?
That's a vertical line.
Damn right it is. Do you ski vertical? What do you call that? Falling. Because this is not a slope, is it? This is what we call an undefined slope. Why? How do I get from point E to point F? Minus, straight down, yes? How far did I go left and right? 0. So this would be a negative divided by 0, wouldn't it? You can't divide by 0. So that is why this is called an undefined slope. Because it's technically an infinite slope, isn't it? Great. So what must this one be? No. If undefined is infinite and vertical is infinite, what is the opposite of vertical? Horizontal. What would you say in math is the opposite of infinity?
Negative infinity. 0.
Negative infinity is still infinity, isn't it?
The opposite.
What would you say it is? Would you rather have, what would it be? 0. Because how would I get from point G to point H? How do I get from G to H? Positive. How far up and down did I go? 0. So I do up and down is on top, right? So if I went 0 up and down, but I went positive on the bottom, can I divide 0 into pieces? Yes. How many pizzas are in front of me? None. How many pieces do you guys get? None. So this is what we call a 0 slope. Straight up and down, undefined, or infinite, because it's not a slope, it's falling. Flat, 0 slope, because if you try to snowboard on that, do you get anywhere? No, you got to do this thing. And look like an idiot while you bunny hop along. Or if you're really good, you do that walkie thing. Where you go nose to tail. I can't do that. I fall down. Or you bend over and push. Or you take out your back foot and you do that awkward skateboard thing that nobody can actually look cool doing. The only time snowboarders get to look cool is when they're actually moving. Otherwise, they look like idiots.
I just look like an idiot in general. So it's fine.
Snowboarders are always sitting around doing nothing because they're so damn tired from going hoppity, 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 hoppity. That's why they got to take breaks all the time. All right. Everybody cool? No, I'm not. All right. Are we all cool with slope being M? Okay, now I'm going to give you guys a whole bunch. No, a whole bunch of ways to define slope. Listen to me. If all of these things equal slope, that means I can use any one of them whenever I need the slope. Do you understand what I am saying? So we know that slope is M. Right?
Correct.
Okay. We also know that slope is how far we go up and down divided by how far we go left and right. Slope is also known as the rise over the run. Rise, up and down, how far you go up or down, divided by how far you go sideways, where you would run. Got it? It's also known as, and this is a very physicsy one, delta y over delta x. Delta is a Greek letter that means change. So if y changes, x changes. Understand? You should know that from science, but I don't teach you science, so I don't know if you do.
I just learned this last week.
Okay? You should also know that slope is a delta in the dv divided by a delta in the iv, because I'm not always using x's and y's, am I? Okay? And it is also, there's one other thing that it is, and I'm not going to talk about that right now because we're going to use it in our next lesson. Have an orange, Mr. Whitman.
Did you see? Did you hear any news yet?
I got an email from our agent to say, have no fear, he's still in the running. They haven't made a decision because there's 2 other kids that they haven't been able to get to LA yet.
Cool.
So he's still in the running.
That's great.
And if he's in like top 5, he might as well be in because people drop out of these things all the time.
Absolutely. That's cool. Thanks.
Why isn't Y always on top of X?
Because the dependent variable, the run, how far you go this way, right? How far you go up and down depends on how far you go that way, right? So when we make the steps, right? How far we go up, how far we go that way is the whole amount, and how far we go up is the part of the whole. Just like when we cut a pizza, right? If you have a pizza, that's 1. We cut it into 2. 1, that is 1 out of a possible 2. So when we're graphing something, if I go out 2, but I only go up 1, then here, I've only gone up the half, and I've only gone out here a half. Understand? Okay, so, again, I told you guys on Friday that what we were doing today would be good review for the test you're writing Tuesday, yes? Yes. So let's do that. This is something you're familiar with from your last unit, correct? All right, except in the last unit, most of the time we called this y, didn't we? Until the very, very end when we said it's also f of x, right? So I can rewrite this as y equals 2x minus 4, can't I? Now, does this look like this? Yes. What about this makes it look like that? There's an X. There's a Y by itself. There's a constant. Okay. So this has all the parts of this, doesn't it? Now we know that that is the Y-intercept, don't we? So what does that tell us? And I'm going to use red because I used red ink. Where can I put a dot on this graph for that function? At y equals -4. Does everyone agree? Everyone cool? Now, if I want to make a line, I need to connect 2 points, don't I? Where's the next point? Well, we know that m is rise over run, correct? What is my m here? 2. What's 2 really? 2 over 1, isn't it, Lexi? So if 2 is really 2 over 1x minus 4, then how far up from that dot do I need to go? Up 2. And you say over. Which direction? Why is it to the right? Because you're right. Because it's positive. Up 2 over 1. Where's my next dot going to be? Up 2 over 1. Where's my next dot going to be? Up 2 over 1. Go the other way. Where's the next dot to the left going to be? Down 2, left 1. Then where's the next one going to be? Down 2, left 1. Is everybody cool? You go to the Y-intercept, and then you use the slope to find the next dots. Is everybody cool? Now, I could connect this line, couldn't I? Because that's continuous data, yes? Everyone cool? Great. You guys do the next 3 lines. I'm going to use a different color for each one. Remember, you can rewrite it as y equals. You guys take 2 minutes. Shouldn't even. So, what do I know about the blue one? Where can I put a dot right now? On which axis? On the y-axis. And what do I know about the slope? It's -1, right? So, that means I got to go up or down 1? Down 1 and then where? Don't say over, right or left? Right, because it's got to be negative, correct? So if I go down 1, 1, down 1, 1, down 1, 1. What happens if I go the other way? Up 1, left 1, up 1, left 1. Everybody cool? What can I do with all those blue dots now? Connect them. Why? Because it's continuous data. Yeah? Okay, where can I put a dot for the green one? C. +5. 1, 2, 3, 4, 5 on the y-axis. Now what? Up 1. Okay, then where's the next dot got to be? Don't say over. Up 1 and right 3, that would be +1 and +3. Right, up 1 and then left 3. Or down 1 and right 3. Down 1, right 3. Down 1, right 3. Up 1, left 3. And then I could connect that line. Is everybody cool? And lastly, my gray line, y equals x. I can put a dot at 0, because it's x plus 0, isn't it? Put a dot right there. And what's my slope?
Nothing.
No. 1. Positive or negative 1, Nick? Positive. So I go up 1 and right 1. Could I go up 10 and right 10? Why? Because 10 divided by 10 is what? 1. Could I go up 1,000,000 and write 1,000,000? If I wanted to, if I had a big enough piece of paper. Could I go down 3 and left 3? Sure. I just did it. Is everybody cool with graphing lines in this form? Is everyone good? Okay. Now I'm going to do something a little weird here. This is where we're practicing from last unit. F of 2. How should that be written if I don't tell you what to look for? That should be, no. F of what? If there's f of x, right? Which means, which line am I looking at? The red, the blue, the green, or the gray for f of x? I'm looking at the red line, aren't I? Why? Because the red line says it's f of x, right? So I must be looking on the red line. F of x, this must be on the red line. Now, it's not f of x though. What is it? F of 2. So the x is now a 2. So on my red line, I got to go where x is 2. Where is x 2?
Y is 0.
It's right there, correct? What's the y value there? 0. So the f of 2 equals what? 0. Everybody good? And see how this is helping us with last unit? H of 3, what color line is H? It's the green line, correct? So from the green line, I don't have h of x, I have h of 3, which means I have to go on the x-axis equals 3. So where is x3? 1, 2, 3. There it is, right? 1, 2, 3. Everyone agree? So now let's go up to the y. There it is right there, correct? What is that y value? 4. So the h of 3 equals 4. Everybody good? Okay. What's different in C? What's different in C? What do I have, Aiden? I have the y value. So what line am I looking at? It's the blue line, right? And now I don't know the x value. I know the y value equals 4. So where do I go on the blue line now? Up to what? 4. 1, 2, 3, 4. There it is. Then I go out here. There's my dot, right? What do I need? A y or an x value for it? I need an x value. What is it? -3. Oh, you guys, it's almost like you're ready for this. If the g of x is 4, x equals -3. And finally, we're back to f of x. That's the red one. Where do I go? I go where x is -1, correct? Where is -1? Right there, -1. And I need the y value. What is it? No. -1 is my x value. Did I read that wrong? Oh, I did. I'm sorry. -1 is my y value. I'm such an idiot. -1 is my y value, so now I need to come over to here. What is that point? Halfway between 1 and 2. What is it? Positive 1.5. Thank you, Sam. Is everybody good? Yeah? Okay, now listen. I'm going to do something right now. You don't have to write it down. Okay? Don't write this down. I just want you to think about it. All right? Everybody promise they're just thinking about it? You're liars. I do not want you to write this down. Without writing it down, just using your brain, tell me how to graph this. Just don't say it out loud. Just think about it. Where will you start? I don't want you to write it down. I want you to think about it. Take 5 seconds. Think about where you're going to put your first dot. And then quietly, so I can't even hear you, tell somebody. No, Nick. Just wait a sec. Quietly tell somebody. Go. All right, now, Nick, where are you going to put your first dot? On which axis? The y-axis. Does everyone agree that Nick is correct? Great. But I can't draw a line until I have 2 dots, right? At least. Where's my next dot going to go? Stop for 5 seconds. Tell a neighbor. Has everybody said a value? Great. Josh.
Down -5. So right 2.
Is Josh correct? Yes. Now, how many dots really should I have to make sure it's a straight line? 3. Because if I put a dot right there, is that a straight line? No. So I'd better check. Where's the next dot that I can put to make sure this is a straight line? Nick. Up 5 and 2 to the left. Does everybody understand? Now, sooner or later it's going to thaw. Let me put in my dot. And then what do I do with those 3 dots? Connect them. Why? Because it's continuous data. Now look at what happens. What if I put in an x of 1? That would be -2.5, right? Right? Plus 2, which would be -0.5, wouldn't it? Check out on this line. There's x equals 1. Right there, right? There's where it hits. Isn't that about -0.5? Yeah. Everyone see how it works? Do you think fractions make this different? Do fractions change this? Do you think? If I gave you this, could you graph it? Just wait. If I gave you this, could you graph it? Where would you start?
At 0 and
And how far up would I go?
2.
To what? 2/3. That would be a real pain, wouldn't it? But what if I did this? What if I said that was the number 1? Could you go 2/3 up now?
Yeah.
Where would it be?
It'd be the second line.
It'd be the second square, wouldn't it? And I need my slope to be what? 3, which is what? Isn't that 3 over 1?
Yeah.
So, where would I go? Up 1, 2, 3, and over 1. And then what's the third point? Because you need 3 points to connect them.
Down 3.
Down 1, 2, 3, and
Over the left.
left 1. Now, here's where I have to see if you really are paying attention. What is that guy's coordinates?
You want us to say it louder?
Sure.
No.
Negative 1/3.
Negative 1/3 and negative 1/3. Because every square is worth a third. Is everybody cool? Now I'm going to show you the only thing that makes this difficult, and I'm not making you write it down on purpose. I want you to see it so you don't have to waste any brain power while you write it. 1, 2, 3, 4, 5. How much is each square left and right worth? 1. How much is each square up and down worth? A third. Does everybody see that? So, if my line went like this, what's my slope?
2 and 1 and 1/3.
What goes on the top of slope? Rise or run? Rise. So how far did I go here?
1/3.
1 and 1/3. How far did I go that way?
2.
2. So what is this slope? 1 and 1/3 over 2. Right? It's not 1, 2, 3, 4 over 2, is it?
No.
Does everybody understand? That's the only thing that's hard about slope, is if you change the scales on one of the axes. Is everybody cool with that? Now, if I ask you to finish this, because that's ugly, isn't it? What is 1 and 1/3? That's 4/3, isn't it? Divided by 2, which is 4/3 divided by 2, correct? Which is 4/3 divided by 2 over 1, correct? Which is 4/3 times what? 1 over 2, which is 4/6, which is really 2/3. So that is my slope. Even though on the graph, it's 1, 2, 3, 4 over 2. Does everybody see that? You must actually check how far you go on the graph, not just how many squares it is. Does everybody get it? But that's only if the scales are different. If the scales are the same, does it matter? No, I can go up 3 and over 2. Everybody cool?
Yeah.
All right. Now, if you look on page 177, you should see this page. 178, damn. I have given you 2 pieces of homework. This in your book is page 180, I believe. Is it? No, I lie. Page 181. 182. Okay. So this is 182. And this, I believe, is 183. On Wednesday is when I want to talk about these, because you have your test tomorrow. If you finish your test early, what do you do tomorrow's class? Those. What should you do right now for 15 minutes? work on those. Or
Study.
study for your test tomorrow, which could mean asking me anything about functions. Okay? Everybody good? Now, when you're doing page 384, guys, listen to me. When you're doing 384, you're going to be tempted to use that. Make sure you actually use the X and Y intercepts. X0 and 0Y. Because they're going to be useful later. So practice with them. That's why I told you to use, for the first page, use that. And for the second page, use Y equals mx plus b. Is everybody good? All right. I'm going to stop the recording. I'm going to upload it. I'm going to take attendance. Then I'm going to walk around. Okay? Go. Attendance is going to take a little while.